Welcome to today's webinar. The topic today is timber beam and surface structures. Today I will present the first part of the webinar, modeling load input combinatorics. My name is Andreas Hörold. I'm responsible for marketing and public relations in the Dlubal Software company. My two colleagues, Bastian Kuhn and Stefan Frenzel, will support me. They will answer your questions, and Bastian Kuhn will present the second part of the webinar, the design, next week, the same time. You can ask questions via the control panel on the right side of your screen. Just a moment, I switch off my webcam that you can see the whole screen. You can ask questions here. My two colleagues will answer you. If you don't get an answer during the webinar because there are too many, you will get an email after the webinar. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. To the agenda today, first point is the modeling of the structure with the beams and surfaces. Second point is entering the loads, and the third point of the webinar is the combinatoric, creating combinations. Okay, then I turn to the program. I start with a new file, new model. The model name is Hall Timber. It should be a 3D model, and we want to create combinations automatically according to Eurocode. As you can see here, we have a lot of international standards. Just note that you need to take this one here, the Eurocode 0 and the Eurocode 5, when you want to design a timber structure and you want to create combinations automatically. That's important, for the serviceability design or building the combinations. Okay, then the national annex is here. I use the German standard, and I edited the settings of the national annex. It's a little bit hidden, but it's important for the combinations. Here you can choose the factors of construction, especially the KDEF factor. And here with the button, the dialog opens, and I can choose the service class 1 because our building is enclosed from our sides, and it's a heated building. The KDEF factor is changed, or has been changed, 0.6 now. Okay, that's all for this dialog. So I changed the work plane to XZ here above, and the view in reverse Y direction. So I start with the first column here left above with a new single member, a beam, but I need to choose a cross-section. I open the cross-section library and I choose a timber cross-section. Dimensions are 160 by 700 millimeters, and the material should be, there's no material, I have to open the library. Timber, glulam, and I use DNAN, and the glulam timber GL28C. Okay, so that's all. And now I can enter here the column. The height should be 5 meters, and I also model the beam, or the half of the beam. So then I double click at the beam and add at this on the start a member hinge. Yeah, hinge about around the Y and Z axis. Okay, okay. And now I divide the beam in the middle, because later we will support the beam here at the edge, in the middle, in that point, and in the middle of the half of the beam. So I open with a right click the dialog here and divide member and intermediate nodes, one node, and now it's divided exactly in the middle. So I divide the beam again. So divide member by distance. Member start 1.5 meters, and I divide also the column. .5 meters from the end. Okay, and now I add here the truss. New single member, new cross section. (160 by 160 millimeters), but a new material. Yeah, softwood timber, C24. Okay. Okay, truss. So from this point to this point. And now it's a disconnected frame joint. So I add a support here, left above, new nodal support. Support in X, Y, and Z direction and around the Z axis. Now it's a typical lateral and torsional restraint. So, and then I can mirror here right above, mirror, create copy. The work plane should be the YZ axis, this axis here, but the point on the mirror plane is here. Okay, so that's all. Maybe one hint, if I created or model it a little bit too quickly, we record the whole webinar, and afterwards, or after my presentation, I will show you where you can find the recording the next days. But I have to do it not too slowly, but not too quickly. I hope you can see and understand it well. Okay, but if it's too quickly, just use the recording in the next days. Okay, then important for the design later, the columns are divided by the nodes and also the beam. But for the design, we would like to consider the whole column and the whole beam here. And that's why I define now sets of members. So I start with the columns. By right click, I open the context menu, member, create sets of members. So I change to the wireframe model, and you can see by the dotted line here that it's set of member now. Yeah, but I forgot to change the start and the end of the member. Here with that option, reverse member orientation, you can change the member orientation. Now the start of the column is here. And that's can be important when you create imperfections. I will create imperfections, and then it's important that the start of the column is at the bottom. Okay, new set of member. Right click, member, create set of member. Okay, so now the whole frame is modeled. I copy it one time. 5.4 meters. Okay. So, and now I create the coupling members, these points here, 5 times. So left above here, new single member, new cross section, (140 by 140 millimeters). But this time, yeah, it's C24. Okay. So 4 times and 5 times. Okay, that's all. Just let me check if I, yeah, okay, C24 was okay. So now I switch to the solid display model. Since that are trusses, it doesn't matter how the angel is, but you can see here it's not the same angel on the upper side of the truss and the beam. Yeah, as I said, it doesn't matter for the trusses, but imagine you have got purlins and you have the purlin here above. You must rotate the purlin. And I would like to show you how to do that easily. I select the 4 trusses here, then I double click, and here under options, general, I would like to define a help node in the XY plane, means that plane here, the cross section. I click at this point here, okay, and now the cross sections are rotated. This one, this one, this one, and this one. Okay, just a tip. Okay, then I copy this again, the trusses and the frame 3 times. So, okay. The frames and the trusses are complete now, and I continue with the gable columns. 3 columns here. I do it this way. I copy these nodes here. 1 time, 2 meters in Z direction, and I edit the expanded settings. So, and I would like to create members between the original node and the copied node. So, and I define the cross section of the member. Should be a beam, new cross section. 160 by 240 millimeters. Okay, and I rotate them 90 degrees. Okay, so now the orientation is correct, but yeah, we are too short. So I double click, or I select 3 nodes and double click at 1 node and say here 0 for the set coordinate, and now we have the correct length. Hide also support. Yeah, the same supports as for the frame columns. So, and the gable columns almost complete, but I need to change the orientation here. By right click I open the context menu, then reverse member orientation. Okay, and now the start is here at the bottom. So, and with double click I add a member end, a hinge at the member end, sorry. So hinge around Y and Z axis, and also a hinge in X direction. So means that a vertical load can't act to the column, but we can extend the hall to a later time. Okay, I copy the 3 gable columns. I need to uncheck that option here. Okay. Then from here to there. Okay. So then I divide all the columns here. Member, divide by distance, 0.5 meter. Okay. Yeah, and that is the point where the platform is located. Okay, I select only the short columns, and let me show you only these columns. So, and I can now the hidden structure is still visible as in a gray color, and I can hide them complete, the beams and so on. In the project navigator display, then is here the option show hidden objects in background, and I uncheck this. Okay, now we can only see these columns here. So I copy them here one time from here to there, 5.4 meter. Okay. So, and now I changed the cross section here for these columns. So, (140 by 140) and C24. Okay, I have to check if the gable column, they are glulam timber. Not a problem. I will change that. It's possible to change anything to any point. I cancel the visibility mode, and I select all the columns. I can also do that by using the views navigator, members by cross-section, and those are the gable columns, and then I can change the material. To softwood timber C24. Okay, so I cancel the visibility mode, yeah, and I create the next visibility. So, okay. Then I continue with the horizontal beams for the platform. New single member. New cross-section. (140 by 260 millimeter). C24. Okay. And hinges at the start and the end. Okay. From this node to this node and this node to this node. So, and since this is the same distance, I can copy them 3 times. From here to there is the vector, 5 meter. Okay. So then the next is the surface of the platform. It should be a CLT panel or CLT plate. I open that dialog here. I need to define the material and the thickness. I can enter here anything because I will change it later in the RFEM add-on module of laminate. I can enter here 20 millimeters steel. We will change it later. So from this point to this and this one. Okay. So that's the surface of the platform. And I will move the beams here on the lower side of the plate with an eccentricity. So how to do that? I select all and then double click on one member, and then here under options you will find the option member eccentricity. I create a new member eccentricity, a relative offset. The upper side of the beam should be on the lower side of the surface. Surface number 1, it's only one surface. Okay. So, and now the members has been moved, as you can see. So, and now we change the settings of the surface with the help of the add-on module of laminate. Here under add-on modules, others, you can find the add-on module of laminate. Now there's an error message, no action has been defined. It's necessary to define a load case at least because it's a design program for laminated surfaces of laminate add-on module. That's why I press cancel here. I enter at least one load case. Load case number 1, self-weight, permanent, and the self-weight is active. Okay, Then I open the add-on module again. And as you could see, the first load combinations has been created. Now only a few load combinations because we have got only one load case. Later we will have more of them. So I select here the ultimate limit state combination. Surfaces, now all surfaces, we have got only one surface. And I use the European standard. As you can see here, all the American and Canadian standards are implemented. So European standard, and I use the German national annex. So then next dialog, I call it slab. The surface is only this surface, and I can enter here materials and thicknesses and so on, but I use the option to import layers from a library. We've got a large library here with different producers. In our webinar I used the KLH producer and played with a thickness of 220 millimeters. Okay, that's the thickness of the single layer and the autotropy direction. Is that the correct one? No, I would like to use this one. Okay. Also the stiffness reduction factors are here. Okay, and now you can see here thicknesses and so on. I would like to change the color from blue to a typical timber color. Okay. That's all what I need to do in the program of Laminate. Next week, Bastian Kuhn will design the plate here in this add-on module. Okay. Yeah, as you could see, the members are moved again in the Z direction. I can show you in the display navigator here under model, solid model, surfaces, the surfaces with, also including thickness, and you can see the member eccentricity has been changed and it's correct. So I use I use the fitted option because the program calculates with the axis of the members and the axis of the shells and plates and slabs and so on. Okay, then we turn to the next point. I would like to divide the slab here in this axis. I create a line, so 3 times. So, and I would like to define line hinges in these lines here. Okay, how to do that? Here left above, insert, model data, line hinges. I assign the line hinges graphically. But first I need to define the settings of the line hinge. I would like to consider spring constants, 7,700 kilonewton per square meter. That's a typical spring constant for connection. And it depends on the connection of the plates. So, and rotational release around the x-axis, near the axis of the line. Okay. Then I need to select the surface and the single lines. Okay, and now you can see the line hinges are created here. So, and between the surface and the beams, I would like to create also a connection, a similar connection, and I need to define line releases. So model data and then line releases. Okay, which line? I start with this line. I need to define it 8 times for all the horizontal beams here. So then I need to define the line release type. So 7700, the same settings. And also around the x-axis. Okay. That's the same release type as for the line hinges. So surface number 1, it's clear. Okay. So the first line release is created, and with enter I can go back to the function, next line, and surface number 1. Okay. So and then I go on with the same workflow. With enter I go back to the dialog and enter the same values. So enter. So almost complete. So the last one. Okay, all line releases has been created. Okay, then I cancel the visibility mode. So the hall is almost complete. We only need to define bracings. I start with the wall bracings. I change to the wireframe model. So left both here, new single member. This time a tension member. And I need to define a new cross section. And on the left side, solid sections. And I use a round 16. S235 is correct. Okay. So then from here to there. And as you can see, there are 2 nodes, one original node and one is generated from the line release. But they are at the same place. I use the original node. So, same here. Okay. And then the bracings on the roof. Oh, and I mirror the other side, or I mirror this side from here to there. So how to do that? I go to the project navigator views and I select only the round 16. Then I select all, the mirror function here, create copy, Y set plane, and this point here is in the plane. Okay. So now the model is complete. So I calculate the self-weight load case to check if I created or I modeled all correctly. Okay, that works. Okay. The deformation is a little bit higher than in my test. Oh, I will check that. Okay, then I need to check if the axis of the surface is correct. As you can see, the x-axis is here in this direction, but I would like to have got the x-axis, the strong axis, from beam to beam. So that's why I double-click on the surface. Now just remember the value here, 6.2. I double-click and then here, axis, and I rotate it 90 degrees. Okay. Okay. I need to select only the platform here. So then now it's 5 millimeters, and if I press undo, okay, calculate all. Yeah, it was 5.7. Then I changed the axis. I can't redo. Okay, I must do it again. $90 degrees. Okay. And now the deformation should be lower. Yeah, 5 millimeters. Okay, that's correct. So I cancel the visibility mode and turn to the solid display model. Yeah, that was the first point of the webinar, the modeling of the structure. And now we turn to the next point of the webinar, the loading. I start with the self-weight load case. With a tool, generate loads from area loads on member via plane. I will enter the load on the roof. The magnitude is 0.5 kilonewton per square meter. And as you can see, the graphic of the load isn't correct. I need to change it to ZL. That's the correct display of the self-weight load. Okay, then I need to define the plane of the load. I change to the wireframe model again to select the single nodes. Okay, first plane and second plane. Okay, that's all. And I would like to remove members from the loading, the trusses. The load should be also applied to the beams. Okay. Okay. So the load is created and I can show you by display separately the load on the beams. And the intelligence is still there. If I change anything here, the load in the plane, the member loads are changing automatically. So you will see that when I copy the load case here in this dialog, copy the load case and call it snow. Change the action category to snow, disable, or uncheck the self-weight. Okay, and now I change the load. Here I need to select here the set P projected area. That's the correct display of the snow load. The rest is okay, but the magnitude must be changed. What is the value of the snow load? I use the tool on our website. Here under solutions you can find the snow load, wind speed and seismic load maps of a lot of countries, and if I check here Eurocode, a lot of countries in Europe. I use Germany and I search for our office in Leipzig. Okay. So, and as you can see here, the altitude is 115 meters. Snow load zone is 2. Wind zone is 2 as well. And no seismic zone. And if you press here on this button, print, you can print all the results with one click. Snow load, the wind load and the wind zone, altitude, and so on. First we need this load, 0.85 kilonewton per square meter, and I need to multiply that by 0.8, and the result is 0.68. That's what I enter here, 0.68, and the load has been changed. Okay, snow load case is finished. We continue with the wind load cases. Before I do that, I turn to the PowerPoint. These graphics here are the graphics of the Eurocode 1, part 4. We need to define for the wind direction 0 degrees for wind load cases. That are the wind loads on dual pitch roofs. The first load case is with pressure on the roof, with suction is the second, then suction, pressure and suction. And for on dual pitch roofs is the wind direction 90 degrees that we need to apply. This load case here with suction. And if it is not symmetrical, as our hall is, we have got a platform on the one side, on this side, and not on the other side. That's why I need to apply another load case with minus 90 degrees. That's why we need to enter 6 wind load cases. I will start with the 4 wind load cases in wind direction 0 degrees. Okay. So new wind load case, wind in plus X with pressure. I copy that, then with suction, and pressure, and pressure and suction. Okay, these are the 4 wind load cases for wind direction 0 degree. So I use another tool here under Tools, Generate Loads, and from wind loads, you can define it for vertical walls, roofs, and walls with roof. I use this feature here. According to Eurocode, I use the German National Annex. The wind zone was 2. I can turn back to the website or to the PDF that I would like to print. Wind zone 2, and the altitude is 115 meters. Okay. So wind zone 2, the terrain category is 3, 115 meter, and the structure height, I can measure it here from here to here, 6 meter. Okay, then I need to define the base geometry. For nodes and the roof geometry for a dual pitch roof. Okay, it's done. The wind load from this side is correct, A minus B, and now I need to define the wind load or apply the wind load cases. Load case number 3, the pressure on the roof, suction. Load case 5 with suction and pressure, and load case 6 with pressure and suction. So then I need to remove some members from the loading. Again, the trusses, and also this trusses here, and the horizontal beams on the platform. Okay, that's all. And all loads are created automatically. I can also display the surface loads. Okay, 4 wind load cases have been created. So I can show you. So wind load case, the combinations are created automatically. So wind load case 3. The load on the walls is the same for all 4 wind load cases, but here wind load case 3, pressure and pressure, 4, suction, suction, suction and pressure, and pressure and suction. Okay. So then we copy the wind load case number 3, one time, plus y, and minus with suction, and I copy it again, minus y and suction. Okay. So, and yeah, I only need to change the parameters here by double click. I only need to change the direction from this side, B, C, D, and assign the load case number 7, suction, and I can press OK, and all loads has been changed from this side, plus Y direction. So load case number 8, double click, direction now from here, EFA from this side, and load case number 8 with the suction. Okay, now from this side here. Yeah, you could see what is necessary to define 6 wind load cases for such a structure. I think it's quite easy with the software, with this tool. Just imagine you need to do that by hand. It would take more than 1 hour or several hours. Okay, we continue with the imposed load case. So new load case, imposed load, that's the correct action category. And as you could see, the load duration has been changed automatically. Okay, this is only one load here, new surface load, 2.5 kilonewton per square meter. Okay, so that was quite easy, and the last part of the loads are the imperfections. So new load case, imperfection towards plus X. I would like to define 3 imperfection load cases in the same direction as the wind load cases acts. Okay, towards X, that's okay. So, and I would like to apply the imperfections on the columns. That's why I select only the columns. Here left above, there's an option select special. On the left side, I select members. Then I need to scroll down here, parallel to member, and I select any column. Okay. So, and now only the columns are selected. Then I press here visibility by selected objects, and only the columns are displayed. So then insert left above, loads, imperfections, dialog box. So there are 3 options to define the imperfections on members, list of members, and sets of members. I show all 3 options. So I start with the sets of members according to Eurocode 5. And I leave these parameters here. Okay, in set direction, strong axis of the members, and I select all the sets of members. Okay, the direction is okay. To define it correctly, there are, you can search for help here with the display navigator. you can select for the members the member access systems, and now you can see here the member access systems. So plus set is here, that's why the imperfection is defined correctly. So we continue with the inner columns. Same dialog, insert, loads, imperfections. Members, and now in Y direction. You can see here the green arrow, that's the Y-axis. Y, members, all members. Okay. So you can see the imperfections are correct, but not for the gable columns here, because they are divided by a node, because of the platform. That's why they are incorrect. One possibility would be to define sets of members, but I would like to show you the third option. Insert, loads, imperfections, and now list of members. In Y direction, these two members, okay. I turn back to the dialog with enter, list of members. Okay, enter. Okay. So all wind load cases are created now. I uncheck here member access systems. So I cancel the visibility mode, and we can go through all the load cases. So self-weight, snow, I can show the loads on the members. Snow, the 4 wind load cases in X direction, plus Y direction, minus Y direction, the imposed load, imperfections in X direction. Oh, that was... I forgot to imperfections. Okay, I need to continue. I copy the imperfection now in Y direction. Okay, and now I only need to modify the loads. I go to the data navigator, and then under loads you will find the load cases. Then here the load case number 11 plus Y, and then here are the imperfections. Then I double click here, change it to Y direction. Okay, that's correct. I need to show the member access systems. Okay. And I can turn back to the previous visibility. So then the members, now in minus Z direction. Here I change it to Z, and here minus. Okay. So, and then these 3 imperfections, I select all of them, double click, then in Z and minus Z direction. Okay. So, and now the last imperfection, I copy it again. minus y. Okay, and I only need to change the signs. Minus, minus. Okay. Plus, plus. Okay. And these three imperfections, double click, plus, plus. Okay. Now also these two imperfections are correct. So cancel the visibility mode, then cancel the display of the access systems. Okay, now we are complete, as the hall is complete and the loads are complete, and we turn to the last point of the webinar, the combinatorics. It's only a short part. I open the dialog again here, edit the load cases and combinations. Here are the load cases, the actions, permanent, snow, wind. The wind load cases act alternatively than the imposed load, and then under combination expressions you can see here the ultimate limit state, serviceability limit states, yeah, the three ones. So, and I define here that the imperfections act with the loads. I select here subject to specific load cases, and I would like to create or apply the imperfections towards X, not with the wind load cases in Y direction. Okay, and the imperfections in Y direction, not with the wind load cases in X direction, and also not minus Y. And similar here. Okay, that's all. And I select here differently for each combination expressions, because I don't want to apply the imperfections to the serviceability load combinations. Okay, then the action combinations are created and the load combinations. 171 load combinations, and 4 result combinations. 1 for the ultimate limit state design and 3 for the serviceability limit state design. Okay, that's all in the program. Before I will show you how to find the recording the next days, I would like to introduce our free online services. I showed the GeoZone tool already. Then you will find the cross-section properties, where you can define parameterized cross-sections, and you can calculate its cross-section properties. The FAQs and knowledge base articles, a lot of valuable articles. Then you can download more than 1,000 models from our website to become familiar or to use it for your projects. Then our YouTube channel contains the recorded webinars and a lot of valuable videos. Our webshop is with prizes. Then you can download our trial licenses of the programs RFEM and RSTARP with all add-on modules. Then the standalone programs are wind simulation, craneway, half buckling, shape fin, and of course the RX timber modules. Now, if you haven't yet registered for our newsletter, just register, then you get information about webinars or trainings or news about our software, etc. But then I turn back to the website. So here under news and events, webinars, you will find the webinar of today, this one. If you haven't yet registered for the webinar next week, just register and Bastian will design the model. So that's today's webinar. You will get an email with a link to that page here. It takes some days, and then you will find the recording here on the left side. You can download the presentation slide, and you will find the model here. Okay, then I turn off my webcam. I thank you for your attention. So it's better. Okay. Thank you to my colleagues for answering the questions. I hope we meet each other next week, same time, 2 p.m. Then have a nice rest of the day and bye-bye.